Greetings, amazing math students of Oshkosh North High School. Algebra 2 class from room 122. Today, I'd like to invite you to join us for our video presentation on equivalent expressions as we begin Chapter 3, Lesson 3.1.1. Let's start by naming several expressions that are equal to 2. Well, there's a whole bunch of it, infinite amount. You could have, maybe you have 6 minus 4 is 2, 10 divided by 5, 1 half times 4. Let's see, 1 plus 1. How about 2x to the 0? How about 5x plus 2 minus 5x? Something called the factorial, 2 factorial, be another one. Reciprocal, let's do a reciprocal one. 1 half to the negative 1. Since we just got done with some square roots, how about if we put a square root in there and maybe a cube root also, cube root of 8 would be 2. Absolute value of 2 is 2, absolute value of negative 2 is 2. And it just goes on and on. You could have an infinite amount of ways to express 2. All these are different expressions, but they're all equivalent expressions. All of them are equivalent to 2. So let's take a look at that situation in terms of more of an algebraic sense. Which of these expressions are equivalent? Okay, so these two are in simplified form, and obviously they're not equivalent. These two need to be multiplied to get to see what they are. Maybe they're equivalent, maybe they're not. So we got your boxes here. So this is 3x squared, negative 15x, negative 10, and negative 2x. So let's see, actually that'd be positive 2x there, positive 2x. Okay, so then we've got 3x squared. You add these two together, and we get negative 13x, and then we've got minus 10. Is that equal to any of these up above? Yes, that was equal to this one. So we know that those two are equal. Maybe these two are equal also, or maybe this one's equal to these. Let's check. So we got our box for 3x plus 5 times x minus 2. 3x squared minus 6x minus 10 and 5x. So 3x squared, add those together, we get minus 1x and then minus 10. Nope, not the same. It's close to this one, but it's not the same. So in this case, the two equivalent expressions were A and C. Now, at first glance, they look different, but they are actually equivalent because they come out to be the same thing. All right, let's take a look at this scenario. Which expressions are equivalent here of these four? None of them are written in simplest. Well, yeah, this one's in simplest form here. So let's see if anything's equal to that or if anything's equal to something else. This is written over here. It's x times 7x plus 1. So we would get 7x squared plus 1x, 7x squared plus 1x. Is that the same as x squared plus 7x? No, it is not. So that those two are not equivalent. How about this one? X plus 7 times x plus 1. That's going to be, here's your box for it, x squared, 7x, 7, 1x. So this is x squared plus 8x plus 7. Nope, that's not equal to either of those two. So far we've got 3 different expressions. Hopefully this one's going to match one of them so we can have some kind of equivalence. So we would take the 3x squared and the 4x squared and add them together to get 7x squared. And then we would take the minus 8x and the plus 9x, and we would get 1x. Is that equivalent to anything we've done so far? Yes, it is. This one right here, it had the same answer. So in this case, B and D were equivalent expressions. Okay, now when you get to the problems on the CPM page for 3.1.1, they are going to ask you to do a multiplication of something that looks like this. And I've included it in the slideshow for you, but let's demonstrate it in this video so maybe that'll be helpful for you. So you'd start by doing the binomials. You really don't have to. You could start by doing distributive property, but I found that it's easier to do the distributive property at the end. So we've got multiply here 2x squared minus 10x minus 15 and positive 3x. So we would get 2x squared minus 7x minus 15. So 2x squared minus 7x minus 15. Now we're going to distribute. We're going to multiply the x times each of these three and see what we get. So this is going to be 2x to the third minus 7x squared minus 15x, and that is our end result of multiplying. And then we would see if that was equivalent to something else that existed in that particular situation. Well, thanks for joining us today. It's your math teacher, Mr. Murphy, signing off from the awesome Oshkosh North High School. Stay awesome, Spartans.